Hello, this is AMET 104 lecture recording week 3.3. Last class we talked about simple interest, so let's do some recap. So interest here, I, is the money that you pay for the use of someone else's money, just like rental property, rental cars, and rental books, things like that. But whatever you pay, but you're not buying, is the interest. So let's talk about the formula. The formula for the interest here, interest is I, is given as PRT. So what is P? So the P here is the principal. So the principal is the money, like a total sum of money owed or borrowed. And R is in this case, APR, is annual percentage rate in decimal. And lastly, the T here is the time in the years. Also, we also talked about F. In this case, F is the bond's final value or the face value. So let's say final value or the face value. They're the same thing, but depending on the context, the one term is more appropriate than the other. And when we're talking about the F, it is actually the original money owed and the interest. So F, the final value or the face value, is simply saying the total money owed after you borrow at the end of the term. And we also have concluded that since I is given as PRT, we can simply write it as PRT. And we went over this, and with a simple calculation, we should be able to conclude that the principal is given as the F over 1 plus RT. So they're exactly the same thing. They're actually exactly the same formula. However, you would prefer to use one formula for one type of problem than another. If the problem is asking for the face value, you would simply use the one at the left-hand side. But if the problem is asking the initial money that you borrowed, the right-hand side may be a better choice in that case. So today, I am simply just going to spend most of the time going over different examples that you might encounter in your homework assignments or quizzes. So let's go over examples. So example, and let's start with something that's very simple and straightforward. So suppose you borrowed let's say $850 for a term of 3 years. And at simple interest, 5.44% APR. And you need to determine the total you must pay back. So simply, the problem is asking, when you borrow this $850 for 3 years at this interest rate, how much money do you have to pay back at the end of the term? So after 3 years, how much do you owe them? So in this case, it's really simple. You would have to find the final value, which is simply the principal plus the interest, because you initially owe the principal and you also owe the new interest on top of it. So let's put down what we know. So we know that the principal in this case is $850. It's $850. And APR in this case is 5.44%. So in decimal, it has to be 0.0544. And we know that we also borrow this money for 3-year term. So from this formula, we know that I is given as PRT. So we know that P plus PRT. And all you have to do is simply plug in everything else you know. So P in this case is the principal is $850 plus the $850 multiplied by APR, which in this case 0.0544, multiplied by the term, 3 years. So plug this into the calculator and you should end up with $988.72. So this means that after 3 years, and with these scenario, you would have to pay back $988.72 to the lender. So that was quite simple, right? Let's do one more that's exactly like this. Example. So suppose you borrowed, let's say, in this case, $645. At the simple interest with 6.96% APR and for 4 years. So with this scenario, how much money do you owe? So how much money do you owe? So from the get-go, we should know that we're trying to find the final value. So we're here to find the F. And let's write down everything we know. we know the principal in this case is $645. We also know that in this case, the APR is 0.0696. And lastly, we know the time frame, the term of the loan is 4 years. Then since we know the formula for the interest is given as PRT, you're simply plugging in everything. So you get 645 plus 645 multiplied by 0.0696 multiplied by 4. Excuse me with that. And by plugging in the calculator, you should end up with $824.57. So at the end of the 4-year term, you owe the borrower, the lender, the $824.57. So as you have probably noticed, in this case, I always mention it's a simple interest. Obviously, up to this point, we have only went over the simple interest and we really haven't learned any other type of interest. But probably, I think next class, we should be able to learn different type of interests, different type of compounding. So it's going to be more complicated. It's not going to be hard, but you would have to make executive decision what type of interest it is. So usually in the problem, it'll state exactly what type of interest it is. So look for these words. So if it says simple interest, you know what you're using, you know exactly what formula you're using. And so in the next class, you'll notice that when we go over compound interest for, let's say, annual compound interest, it'll actually state exactly that language in the problem. So there should not be any ambiguity, but read the question multiple times to make sure which formula that you are supposed to use in each of those cases. Okay, so that was simple enough. So let's go over an example now that's maybe a little bit different, but not necessarily harder. So last time we talked about a bond, so bond. We also talked about the CD, the certificate of deposit. So these cases are the money that you're investing. So you're not the one that's borrowing the money, but you're the one that's lending the money to any sort of financial institute, government, or for whatever project it is. So you're simply lending the money to the agency, and at the end of the term, they're paying you back for however much that they owe with the interest. So let's look at an example. So suppose a 4-year bond is purchased with an APR of 5.75%. And let's suppose that the face value of the bond is $8,500. So what's the purchase price of the bond? So you're trying to find purchase price. of the bond. So the face value is the same formula that we're using as above. So the face value, we know that it's given as P plus I. And let's write down everything we know. So we know that, first of all, the face value is given as $8,500. We also know that APR was 5.75%, so it's 0.0575%. And the term was 4 years. And you are trying to find the P, the principal. So how do we do that? So we know that the face value is equal to P plus I, but we have also established earlier that this is exactly the same as saying that the principal is equal to face value divided by 1 plus RT. So in this case, since you're trying to find the P, it'll make more sense to use the formula on the right-hand side than the left-hand side. It doesn't mean that the left-hand side formula is wrong. They're actually exactly the same formula. However, it'll save you a lot more time to use the right-hand side, but you can very well find the same answer just using the left-hand side. So if you think it's necessary, you can simply memorize this formula and just use it. But if not, you can still get there without any hassle. It'll probably add maybe a couple more steps, but it's not too much of a problem. So in this case, instead of this, we're going to use, so let's use the equivalent formula, which is the purchase price, the P, is equal to F over 1 plus RT. So we actually know everything else that's needed in this formula. So we know that the face value in this case is $8,500, and it's divided by 1 plus. So here R, the APR in decimal, is 0.575, and you're multiplying by 4. So in this case, you would need to put this into calculator to find it. And I'm sure most of you are already proficient at using this calculator, but when using the calculator, trying to find this, make sure you do the denominator first and make sure you do the multiplication first. If you simply plug in 8,500 divided by 1 plus this, it's not going to get you the right answer. I mean, you can do that, but you would need to put the appropriate parentheses. I personally think it's easier to go by order of operation. So you simply do the multiplication in the denominator first, and then you add the 1, and you simply divide the $8,500 by whatever you found earlier. So plug this in the calculator, and you will actually end up with $6,910.57. So that is the initial amount of the bond. In other words, this is how much that you lend the agency that we're talking of here. Let's do another example that involves bond. So let's say, example, 6-year bond is purchased for let's say $5,400. And the face value when it matures is, in this case, $6,615. And you need to find the APR. So this is a different type of problem. So we are given the term as 6 years, and we also know the principal, how much you purchased the bond for. And we also know that the final value or the face value of the bond at $6,615, and the one thing that we do not know here is the APR, and that's what we're trying to find. So let's go over this problem. So we already know that the face value is given as P plus I, the principal plus the interest. And we, in this case, we know that the principal is already given as $5,400. And we also know the face value is given as $6,615. And we also know the term of the loan is 6 years, but we do not know the APR. So let's plug in everything we know. So this is actually the same as saying, so PRT. And we know that the face value in this case is 6615 is equal to the 5,400 plus 5,400 multiplied by R, which is what we have to find, multiplied by 6. So we actually just established an equation where we have everything else, but we only have one variable that we need to find. So this should actually be very simple. Let's actually do the calculation then. So first of all, we want the R on one side and everything else on the other side. So what you would have to do is you first subtract 5,400 on each side. Then you would end up with, so on the left-hand side, you would end up with 1215. On the right-hand side, this will simply cancel out, and you would have 5,400 multiplied by R multiplied by 6. So let's do it one by one. We can do everything at once, but let's do one by one just so we know exactly what's going on. So now, in order to get rid of the 6, we're dividing 6 on each side. Then on the right-hand side, you would still have $5,400 multiplied by R. But on the left-hand side, you would end up with 202.5. And lastly, you would divide each side by 5,400. And that should simply give you R on one side because 5,400s cancel each other. And here, what was on the left-hand side would actually become 0.0375. So this is actually the same as saying that so R here, that what we didn't know was 0.0375. So what's the APR? So APR has to be in the percentage. So the APR is 3.75%. Simply by changing, converting the decimal to the percentage, we can deduce the APR like this. Let's do another type of example that involves bond, but this may actually be a little more confusing if we actually didn't go over it together. So find the APR of a bond that doubles its value in 26 years. So that's all you're given in the problem. So you're not given as much information as before. So we're not given the face value, we're not given the principal. All we're given is the term. So we know that it's 26-year term. But that's the only thing we know. And what do we have to find? So we have to find the APR. So let's go over, let's use the same formula. So the face value equals to P plus PRT. Here we know that the term is 26 years, but we do not know anything else. In the previous problem where we also had to find the APR, we were at least given the principal and the face value. So how would you approach this problem? So the easiest way to approach the problem is that you can simply choose any number. You choose any number for the principal and make sure that the face value is double. So choose any number that's, so choose any value for P that is easy to work with. And since we know that in this case the bond is doubling, and just double the value of the P and let it be F. So this, just by stating this, may not be as clear as it really is. So let's actually do an example that's easier to work with. So what's an easier number to work with for P? We can actually use 1 because it could be any number. It could be just, you can say it was a bond that cost $1, or it could be $10, $20, or even $1,000. So let's say $1,000. So we're letting the purchase price of the bond to be $1,000. Then, since we already know that the bond doubles, then since it doubles, let me actually write everything down. So since the bond doubles, the F must be $2,000. So it really doesn't matter what number you choose for P. I personally think that $1,000 is a very easier number to work with. But if you think 1 is an easier number, you can simply choose that. Or if you think $1,200 is an easier number to work with, you can do that. You just have to make sure that the final value is just double the purchase price. Obviously, you cannot put 0 in here, but then because the double of 0 is still 0. But this is, in this case, I'm just going to use 1,000 to be the number. So let's let P to be that and F to be that, and we already know what the T is. Then we can actually use the same trick that we used last time. So we're plugging in everything we know. So 2,000 equals to 1,000 plus 1,000 multiplied by R multiplied by 26. So simply by subtracting 1,000 on each side, we would end up with 1,000 equals to 1,000 multiplied by R multiplied by 26. And you can also divide each side by 1,000. To have, so in this case, this cancels out too. So it's going to be 1 equals R multiplied by 26. So this would actually imply that R equals to 1 over 26, or in decimal, it'll be 0.0385. So this would actually imply that it's the 3.85% APR. So I'm not going to go over the same example again with the different number. I'm not going to use 1 or 100 just to show you that it actually ends up with the same APR, but you can do that in your own time, and you can actually confirm, and you should be able to confirm that you should really end up with the same APR. So when you receive problems like this is how you approach the problem. And also, one thing that I wanted to mention, even though it's very minor, a lot of the times I've noticed students, when they are canceling out the same numbers, they simply write this as 0. It is not 0, it is 1. When you're dividing and canceling out. So as a fraction, this is a ratio. So think of it as 1,000 to 1,000. That's a ratio. It's exactly the same as 1 to 1. You're not eliminating it, but you're rather simplifying it. But obviously, when you are subtracting, you can simply subtract the number from whatever it is. But when you're dividing on each side, you cannot simply make it 0. It always, just think of it as a ratio. So this is not 0, this becomes 1. What else did we look at? So last class, we also looked at this example that's called the payday loan. So the payday loan is a type of loan that you borrow from this company for a small sum of money that you borrow, and it usually has a very short term, and they charge some fee for taking out against your paycheck before you actually receive it. So let's do an example. So let's say a example. Let's say a particular payday loan company offers quick and short-term loans using the borrower's future paychecks. As collateral. And let's say the loan company charges $17 for each $120 loaned for a term of 12 days. And here you have to find the APR charged by this company. So we went over one example like this last class, but I know a lot of the students get confused with this type of problem, so I thought it may be beneficial to go over problems like this. So let's write down what we know. So we know that in this case, we're borrowing. So suppose we're just borrowing $120. So in this case, we are borrowing the principal amount of $120. And then the company charges $17 for the interest. So as a consequence, we will end up with the I equals to $17. And the term in this case is 12 days. So for 12 days. What's the formula that we know involving simply the principal and the interest? It's a simple interest formula. So let's do that. So let's say I equals PRT. So here we already know the principal, the money that you borrow, is $120. And we also know that the interest is $17. So let's plug that in first. $17 equals $120, and you multiply by the APR that we're trying to find, and you're trying to find, you also have to put the T down. So here, what is the T? It's easy to fall into this trap and simply put 12 in there because it's 12 days. But it is not, because here R is the APR. So R is the APR in decimal. We often abbreviate and just call it APR, but here A implies annual, so it's annual percentage rate. So in order to calculate straight like this, you actually have to convert the 12 days into years. So it has to be in the unit of years. So you have to convert days to a unit of years. So I know this may not sound too intuitive because 12 days is smaller than a year. How do you change it to a year? So all you have to do is take the number of days, and since we know there are 365 days in a year, you're simply doing 12 divided by 365. So let's plug this value into the T here. Then you will end up with $17 is the interest for borrowing $120 for whatever APR it is that we're trying to find. We know that the T here, the term, is 12 days out of 365 days. So we actually now have established the equation that involve only one variable. So now it's easy to find the R. So I'm not going to calculate each one, but let's still do the step-by-step thing. So from here, by simply dividing 120 on each side, you should end up with 17 over 120 on the left-hand side. On the right-hand side, you should have R multiplied by 12 over 365. And the next step would simply be by dividing 12 over 365 on each side, you should end up with R equals to 17 over 120 multiplied by 365 divided by 12. So if you calculate this, if you put this into a calculator, you should achieve, it's approximately 4.309 ... So what does this mean? So this actually means that the APR is 430.9%. So in this case, even though owing $17 for borrowing $120 for 12 days may not seem like a lot, but in reality, the APR is 430%, which is a huge amount of margin that they're really making. So I think I'm going to cut it here and let you go a little early today. Next class, I'm going to start with the compound interest, and it's going to be a longer chapter. So we might take a couple of lecture periods just to go over the materials before we do any type of examples. But thank you for joining and have a great rest of the day.